Here I introduce the idea of integral and derivative 3x plus 1 sequences. And no, this has nothing to do with calculus. I'm using these terms descriptively in the context of the Collatz conjecture. I'm defining an integral sequence as one for which the first odd number cannot occur in any other sequence. A derivative sequence is every other kind of sequence, all the rest. Integral sequences have two necessary properties. The first number must be an odd multiple of 3. That is, n is congruent 0 mod 3. Such a number cannot reoccur in another conventionally defined sequence by virtue of the 3x plus 1 operation. The second property is that the following number must be of the form n minus 1 times 1.5 plus 1. And such a number would belong always to a following derivative sequence by virtue of this property. Here is a table of odd-only consecutive sequences, and we see the integral sequences are 12 apart: 15, 27, 39, 51, 63, 75, and all the other sequences are derivative. And if we take one example, 29, we see that 29 belongs to multiple sequences, as shown. Derivative sequences are finite by definition. The reason this must be so is because they always contain an element of a shorter sequence that is itself derivative. And this nesting property begins with the first sequence, input 5, output 1. In the previous slide, I showed the example of 29, which is present in multiple sequences. All those sequences are derivative because all the numbers following 29 will be the same. The question is, can you prove the second number of an integral sequence can never be the first number of a subsequent integral sequence? That is, the operation n minus 1 times 1.5 plus 1 can never result in an integral sequence if the input is an integral sequence. So we see 50, input 15, output 23, input 27, output 41, input 39, output 59. In no such case can the number in red be the beginning of an integral sequence. Well, using this idea, we have the basis for a proof by contradiction. It's a little twisted, it's a little tortured, but it works. The statement is, if n minus 1 times 1.5 plus 1 always begins a derivative sequence, then all integral sequences must also be derivative.